Okay, when factoring, remember that you always factor out the GCF first. No matter what the directions say, this is always something you check for first. Then, if you've done that, then what you want to do is, if you're given a trinomial, you're going to find the sum and product and try to factor by grouping. If you're not given a trinomial, I'll go over what to do for that in another video. Okay, so let's say that you were given the polynomial 2x squared plus 10x plus 12, and the directions were to factor. Well, the first thing that you would want to do, again, it would be to factor out the GCF. So I'm looking at these three terms, I see that they're all even numbers, so that helps me figure out that I do have a GCF. The GCF here is 2. So I would want to factor out a 2 from each term. I cannot factor out an x from each term because not every term has an x. So then I would be left with x squared, or I could write a 1 plus 5x plus 6. I'm dividing 2 from each term. Alright, now this is where it gets interesting. Since I have a trinomial, and mainly I have a trinomial that has an x squared, an x, and then just a number, this is the type of trinomial that we can factor, I'm going to find the sum and product. Alright, the sum and product you find, first of all, the sum is found by the middle term, the coefficient or the number in front of x, so that's positive 5. Alright, the product, alright, which I'm going to abbreviate here, is found by multiplying the first number or the coefficient in front of x squared times the last number, which is positive 6. 1 times 6 is 6. Okay, notice that I did not use the GCF2. Okay, now when multiplying and adding, you can use your calculator to help you with this. This one's a fairly easy example. Thinking about the numbers that multiply to 6, we have 1 and 6, but they do not add to 5, so I won't choose them. Also, I have 2 and 3. Those do add to 5, so I will choose those. If 2 and 3 didn't work, you would have to continue looking for factors, but 2 and 3 work, so we're ready to move to the next part. Now notice our GCF2, I'm just going to keep writing it. It's not going to do anything in the problem, but I will keep writing it. Trinomials are great, but what I really want is 4 terms so that I can have 2 groups of 2. So I'm going to rewrite the inside part as 1x squared plus 2x plus 3x plus 6. So if you didn't catch it, what I did here is I took my numbers 2 and 3. Because they add to 5, I split up 5x into 2x plus 3x. Okay, now I have 2 groups of 2. So what we want to do, again, rewrite the 2 at the bottom. It's not going anywhere, but we have to write it. What is the GCF of the first pair? Well, in x squared plus 2x, they don't share a common number other than 1, but what they do both have is that x. So that's the GCF that I'm going to factor out of my first group. So I factor out an x from x squared, I'm left with x. I'm dividing out an x from x, and I'm left with x. Okay, when you divide out the x from 2, you're left with 2, or 2x, I'm sorry. So notice that what would happen if I were to distribute x times x, that equals x squared, x times 2, that equals 2x. So I know I did that step correctly. All right, now I have a plus, and I need to find the GCF of 3x and 6. Well, they both look like multiples of 3, and that ends up being our GCF, 3. Open up parentheses. 3x divided by 3 is x, and 6 divided by 3 is 2. Now, if you notice, what happened here is that in parentheses, I'm left with the same term. So here I have an x plus 2, and here I have an x plus 2. That will always happen if you're doing the problem correctly. Okay, so now we're ready to write our answer. This is the last thing. So again, my GCF of 2, I have to write that, and I'm going to group x and plus 3 together to make one term, x plus 3. Then I'm going to take this repeated term, x plus 2, that's my other factor or my other group. And this is your answer. Alright, now there are two ways to check your work here. One of the ways we'll get, probably the easiest way to do this, would be to check it in our calculator. So I'm not going to show that in this video, but I am going to write down what you would do. You would plug the original problem into y1, and you would plug the answer into y2, and you would check to see that their tables match. The other thing that you could do would be to multiply out 2x plus 3 and x plus 2. Okay, if you were to multiply this out by hand, you will be left with 2x squared plus 10x plus 12. I'm not going to show how to check it by hand in this video, but please ask me if you have questions about that. Probably your best bet in checking your answer is going to be if you plug the original statement in y1, plug your answer into y2, and check to see that your tables match. That's going to be the easiest way to check these examples. Okay, let's do one more example with factoring. Remember that our first step is to always check for the GCF. So thinking about the terms 3x squared plus 13x minus 10, what would be the GCF, or what would be a term that they all share? You may be thinking 3, but 13 is not a multiple of 3 and 10 is not a multiple of 3, so I can't factor out a 3. You may be thinking an x. The first term and the second term have an x, but the third term does not. So even though we checked for the GCF, we're going to go straight into the next part, which is to find the sum and product. And on this one, I'm going to use S for sum and P for product. So the sum, remember, comes from the middle term. The middle term is positive 13x, so I am going to write positive 13. Over here on the side, we're just going to write the numbers. The product comes from multiplying the first number times the last number. 3 times negative 10 is negative 30. It's important that if your number is negative that you do write it over here. Now there are a lot of factors of 30. If our product is negative 30, one of the numbers needs to be negative. So let's start with 1 and 30. One of the numbers needs to be negative and it needs to add to 13. Now whether the 1 is negative or the 30 is negative, they will not add to 13. So let's try the next factor pair, 2 and 15. Now, I know that 15 minus 2 is 13, so if the 2 were to be negative and the 15 were to be positive, this would be the correct factor pair. If it didn't work, you would go on and use other numbers, other factors of negative 30. You can also remember, use your calculator. What you would do is you'd go to y1 and you'd type in the product, which is negative 30, divided by x, and you would go look at your table, and your table would give you all the factor pairs, and you would just have to figure out the one that has a sum of 13. So that's what you would want to do if you're having a hard time. Okay, let's go back to our problem and let's finish it out. Alright, so we have our two numbers. Our numbers are negative 2 and 15. So I'm going to rewrite my trinomial 3x squared, but instead of 13x, I'm going to write minus 2x and plus 15x. We can see that these two terms definitely combine to make positive 13x. So what I've written here is good. First thing in the second group, the first pair, the GCF, 3 and 2, they don't share any factors, so the only common term in the first pair is x. You would factor out an x by dividing out an x from each term. I would have 3x and minus 2. Alright, plus. The second pair does have a GCF. It does have a greatest common factor, and that number is 5. Remember, when your GCF is a number, you divide that number out. So 15 divided by 5 is 3. Negative 10 divided by 5 is negative 2. Okay, so now I can see that I did this correctly because I have the same term in the parentheses. That should always happen when you're doing this correctly. All right, now, the reason we call it grouping is because we're going to group the x and the plus 5 together. Because they're both being multiplied to the same term, I can combine them to their own group, x plus 5. And 3x minus 2 is obviously the other group. That's our answer. Now remember, there are two ways to check this. One way, which is the easiest way that most of you will do, will be to plug in the original statement into y1 and the factored answer into y2 to see that the tables match. The more algebraic way to check our answer would be to actually multiply our answer out by breaking it apart into two groups, and that will give us the same answer. On another video, I will explain what to do if instead of a trinomial, you're only given two terms, a binomial.